All right, folks, we're gonna get going tonight. Pardon me, a couple things. Hi, my name's Jim Gal, for those of you I haven't met before. Sorry, it's been 3 years since I actually talked to anyone. Thank you all for coming. We're gonna try to get this back off the ground and be here every month. So the good people at 7C are gonna be sponsoring this from now at least through the end of the year and see how it goes. As long as we're nice people, they'll let us come back. So we appreciate having you sponsor. We miss the Swiss, but it's nice to have another place local that's kind of supportive and central. So we're happy to do that. I am a faculty member at Tacoma in Interdisciplinary Arts and Sciences, and this is now, I think, our 6th year of doing this, which is super fun. It survived through Zoomland. I appreciate all those folks actually check this out online. But I was just about done with that when we finally were able to kind of get back here and find a new sponsor. So doing it from your home without people around is really not the same thing. So super excited to be back here. So we do have our lineup coming. So my boss is going to be, so you better be here. My boss is actually going to be here in March. So our new dean in IAS is going to talk about her specialty, which is repulsive Renaissance poetry, which there's just no way they can't be good. So I hope you'll come back. If nothing else, we'll come up with a whole bunch of great quotes we can put on a coffee mug and make some money off of it there. So come back on March 14th to see Dean Eschenbaum give her talk. Otherwise, things we have coming up. We have a talk on wilderness. We have a talk on beer. And we have a talk on student success coming up. And you may hear from me in April if I can't find another speaker. So just to warn you, I want to skip that one. But otherwise, we hope to see you here. Oh, our March speaker just walked in, so just put her on the spot. Give it a talk. So hope to see you all here. As we found out, hopefully there is food here now. So it's kind of a separate company within the same building, so you can go put your order in. I feel like we're going to get used to the beepers going off in here, so that'll be just fine. Get your beers and have a good time. So for those of you, anybody new to this? A couple people, awesome. So we'll thank you. Tell all your friends. I right now don't have a listserv, so we keep up on the website. So the website, the Grit City. If you just Google Grit City Think and Drink, you will find the web page. It has the upcoming talks and when they are, that sort of stuff. We'll all be back here. So check that out and spread it to your friends. We will introduce our speaker here in a minute. He'll get an amazing talk and give him a short break, and we'll give away some prizes. We are down to, we've done this over 6 years. So there were t-shirts. So those went fast. And then we have hats. I'm slowly wardrobing myself. And we are down to our last pair of socks. So we're going to give away our last pair of Good City Think and Drink socks today, as well as something that I call it the white elephant gift. So you get something else. But we'll be working on what we're giving away next. So we'll give away some prizes, and then you get to stop the speaker and ask whatever questions you want the speaker, and we'll get you out of here after that. Or stick around and have a good time. Sound good? I do want to warn you. So because of 2 things going on, they don't want us to use the sound system in here. So hopefully you can hear okay. Just put your thumb up to see the speaker to speak a little bit louder. This is just for recording the talk. It's not actually an amplifier. So it feels like you can't hear it because it's not doing that. Okay. But that way, people want to show it off. Like the talk will be up online afterwards. Send people to check it out. Sound good? Excellent. So I will in a second. I'll get Andrew's talk up, but I'm going to introduce him first, and he can come up while I get his talk up. And I forget how to do this on paper because I've been doing it online so long. So I'm just going to carry my computer around like this. So we're going to talk about Andrew Erickson is assistant professor in IAS. He's assistant professor of mathematics education. He's been here since 2017. He studies the intersection between information literacy and mathematics education from several perspectives, trying to better understand how people use tools, including other people, to learn about the world both in and out of school settings. So hopefully you get a lot out of this talk, and we'll come back and think about all those questions you want to ask. So Andrew, it's all yours.
So I'm usually pretty good at projecting. I do have like a head cold right now, so yeah, please tell me if I'm not loud enough. Thank you so much for coming. The title, I feel, is maybe a little bit of a misnomer. I'm gonna do maybe slightly meandering exploration of some questions I've explored over the years. And there's going to be a little bit of interaction. I'm going to want you to ponder a few things as we move through it. One thing I changed in the title. The original title said understanding the new relationship students have. I actually removed the new because well, as we'll see, I think this is the phenomena that I'll describe, I think, has been with us for a long time. Okay, so without further ado, let me. So here's a question for the audience. I'd like you to maybe just quickly chat about it. Suppose that you need to solve and understand a small math problem that's on a topic that you once understood, but now it's been a long time. You know, it's back in high school. But you have to do it. What resources would you draw on? What would you do if you found yourself in that predicament? So people right next to you, you want to just ponder that for a moment, talk about it? Okay. Okay, we'll pause for a moment. We'll return to a kind of similar question, a little more specific one in a little bit. But is somebody willing to say something that they or the person they were talking with suggested? Yeah. Say it again. Google. Okay, you Google it. Leanne? Aha, yes. Yes. YouTube. Google, YouTube, colleague. Yeah. Okay. Hanging on to the old. That's wonderful. I'm happy to hear that. So just kind of keep that in your mind. This is kind of like a space that I want you to be pondering. And again, there'll be like a couple more specific questions in a moment. So the topics I'm going to be covering are three. One has to do with thinking about math classes and the way that in this day and age, one might argue that all math classes have sort of this online component. The second thing I'm going to talk about is a little more philosophical, talking about how, what grounds do we have to say that we know things, and how does that link up to the way that students explore things online? And the last one, questions and answers, are not just questions and answers, is going to be exploring a little bit more about how knowledge is established and developed and verified online. And sorry, one other thing, the slides are maybe a little out of order here, but also want you to imagine three hypothetical students, Sam, Sadie, and Marks, who are, they are in this situation more or less. They're having to try to figure out a math problem, and they have to think about how to go about it. Okay, so I'm studying a big thing I'm studying right now is how students use the internet to study math. So why study how students use the internet to study math? Well, so first of all, as would probably come as no surprise, the learning environment for students is very much tied deeply to the internet. You in the classroom, you have laptops with them, and really, I'm talking about college students here. So you have laptops, you have smartphones, you have all these resources at hand. Also, as I came to find out, there is very little information about how students are making use of online resources when they're studying mathematics. I hypothesized, I conjectured that it could be the case, and this conjecture was borne out, that students may have very different experiences of schooling depending on how they are navigating that information environment that they live in. So essentially, you stick students in different elementary school classrooms, high school classrooms, it might look pretty similar, but once you get into a more sort of a classroom setting where it bleeds into the online environment, all of a sudden students could be interacting with that online environment in very disparate ways. So they can have different experiences of instruction. Also, there's a big, very well documented issue that a lot of mathematics courses can serve as de facto kind of gatekeepers. They can present a barrier for students, and as noted up there, it tends to disproportionately harm non-traditional first-generation minoritized student populations. So that was sort of the pressing concern. I won't actually be dwelling a lot in this exploration on that facet of the question, but that's part of what motivates this particular investigation. So the thing that kind of contrasts with this sort of capacious information environment where students can just grab from everything is something that's sometimes called sequestered problem solving. It's this idea that holds not in every educational setting, but in many educational settings, that the way to demonstrate knowledge, that the goal in many ways is to be able to demonstrate, to be able to solve a problem in a closed off setting. You have very little access to other things. You need to have memorized pertinent information. You need to just be able to deal with the problem right there. This is not, I think, what real life problem solving tends to look like, right? I mean, you can probably think of times today or in yesterday where you had something you were wondering about or was trying to learn about, and generally you're not closing yourself off from the outside world. So to think about this shift from what we might call sequestered problem solving to the more needing to draw on the outside world. Now I want to ask you a couple of very specific questions. So with the people around you, what does 3 + 3 equal? You talk to each other, see if you can come to a decision. Do something real quick. Okay, I think I heard the right answer. Somebody want to say 6? Okay, how do you know that? Huh? You count it on your fingers. You might have it memorized at this point. You could use a calculator. Okay. What about this one? What is 3 to the power of 27? So you can use. So can you figure that out? So you can use a tool. You can use tools if you want to. So raise your hand if you got it figured out. What did you get? A lot of numbers. How did you get those lots of numbers? Okay, you Googled it. 3 carat 27. The little symbolizes yeah, symbol for taking the power. Okay, how about this one? What is this?
Beats the crap out of me.
Try to. You can use whatever resources you have at your disposal. You have a smartphone, you can make use of it. And chat with the people next to you, see if you can figure out what that is.
I've never seen that.
Yeah. So let me see, did anybody come up, not necessarily with the number itself, but with some idea as to what it is? Yeah. Okay, how did you know that? Okay. So wait, how many times do you take 3 to the 3 to the 3 to the 3? 3 to the 3 to the 3. It's actually not. In the right direction. Did anybody, Rita, did you Google it? You didn't? Did you find it, Hillary? You have it?
Hierarchy of things, and then usually you calculate it in reverse order. Take the top 3, that's 3 to the 3, and say, well, what's that number? Then come down the way.
Yeah, so this so this is something that I think most people, even most mathematicians, would in fact have to look up. It's not something that even most mathematicians know off the top of their head. It's something called Knuth's up arrow notation. It's used to represent extremely large numbers. It was used to represent the largest number that was used in a mathematical proof. I don't know what that number was off the top of my head. That number right there is, you take, it's what's called like a hyper operation. So if you just had 3 up arrow 3, it'd be 3 to the power of 3. If you have 3 up arrow 3, it's 3 to the power of 3 that many times. So 3 to the power of 3 to the power of 3 to the power of 3, like 27 times. So that's something in the trillions. The third up arrow means that you're taking 3 to the power of 3 to the power of 3 that many times. So you're doing 3 to the power of 3 to the power of 3, something like 7 trillion times. So this is literally a number that you can't, a lot of you probably remember scientific notation times 10 to the power of that. This number cannot be represented in scientific notation. There'd not be enough atoms in the universe to represent this size using scientific notation. Like scientific notation is to represent large numbers. This is too large for that. It breaks the bank. And it's like something you most people, again, including mathematicians, have to look it up. You have to, for the most part, don't know what it is. So I'm gonna pause for a moment. I'm gonna note that part of the context for those problems I just showed you is that some of the research that I've done has to do with having students explore problems like that with the idea that they are allowed, if they wish, to use the internet to help solve the problem. And then they talk through it. They narrate what they're doing. This is part of a sort of larger study that involves surveying and interviewing many students across the country. one of the findings is that most students, almost all of them, are using the internet extensively to study mathematics, and I specify this is specifically in ways that are not like required by the instructor. So we're not talking about, oh, they have to use it because it's part of the course, using it in other ways. They use the internet in many different ways. So at the beginning, you brought up YouTube. So they look up lectures on YouTube. Answer engines. There's a thing called Symbolab. There's a thing called Wolfram Alpha. There's a thing called Integral Calculator. Students can use these answer engines to give them a worked out solution to a somewhat sophisticated math problems. There's problem banks like Chegg, where just there's answers to questions. And there's Wikipedia, which students don't use very much at all, but they're aware of. And more to the point, many students experience tension around the use of these resources. It's kind of like a free-for-all, right? There's not like a lot of norms around how, where, why to use it, what's the best way to use it. They're sort of exploring the space on their own. So with that in mind, I want to share like a few cases. These are actually specific students that I've talked to, but they're anonymized, of course. So this first one, Sam. So this student never used online resources in high school. Most students don't use them as much in high school, if at all, because they have much more kind of ongoing support in high school. They're now taking calculus at a community college and kind of struggling. They still don't use online resources, but they do make use of the tutoring center. We observed Sam try to solve an integral that used a technique that had not been introduced in class yet. They did use the internet, but they encountered difficulty because they did not want to type in the problem itself. They felt like it would be cheating if they just typed in the actual problem. So instead, they tried to describe the problem without doing the specific problem, which, as you might imagine, is kind of challenging. And that was unsuccessful. They were not able to arrive at a correct solution. That was that, basically. Sadie. So Sadie, she oftentimes gets stuck while working on math homework. So she just immediately opens up Symbolab, which works out problems for her, or YouTube sometimes to find help. She didn't do this in high school either, but she began seeking out resources when she noticed that college math was moving at a faster pace. Symbolab helps her with small errors. But if she, in her words, if I wanted to completely relearn it, then YouTube was more helpful than Symbolab. Like if she wasn't gelling with the professor, didn't quite follow the lecture. And then again, in her words, we would have online homework programs that gave you a certain amount of attempts. Sometimes it would flash you a red X if the answer was wrong. If I couldn't get it right, then I'd use Symbolab, bring it up. We observed Sadie trying to find an answer to an integration problem, much like the one that Sam did. She immediately went to Symbolab, brought up the solution, but she didn't just like write down the solution. She looked at the specific steps in order to remind herself how to work through the problem. She then reconsidered the worked out problem once she had her own solution. In order to check her work, she successfully solved the problem. Marks has an online textbook available to him. It does include videos, but the videos, in his words, they seemed really outdated and unhelpful. So he uses Google to search for videos that address concepts that he's learning about. These are usually Khan Academy videos. This is from him. I think mainly I looked it up again just to solidify my knowledge in how to use this law of sines and law of cosines. Sorry, that was a transcription error. It should be SINES. So basically just kind of like a cheat sheet. So I follow one example of how to do it, and then I apply that to a different problem that I had assigned. And then with using the patterns or the steps that I did from what was used on either the website or the video. Yeah, he's conceptualizing this as a sort of cheat sheet that gives him sort of templates for how to solve these problems. When we observed him working on the problem, he immediately used Google to look up the specific problem, the thing Sam avoided doing. He says, see, I just did a quick Google search, went to the first link. Okay, this basically just has all the steps, so I don't want to view the answer yet because I want to know what we're doing here. Then he proceeded to identify a specific step in the problem that he did not understand. It involved a trigonometric identity. He pulled up a second tab so he could review a list of trigonometric identities. He was still having trouble understanding the step. And so then he notes that he would treat this differently depending on the context. He said, I would just use this. If this was a homework problem, I'd just use this answer, even though I don't quite understand it, I just use it. He then clarified that if you were studying for a quiz, you would take more time to sort of relearn the material. So there's this tension about like, how much is it okay to rely on these resources? Which resources are okay to rely on? Which can I trust? And so I want to segue a little bit here to get, this is going to touch a little bit on some of the, I don't know, epistemology, the philosophy of science a little bit. So is dependence on others a problem? There's a huge cliche that people are probably familiar with, this idea of the hero scientist, the scientist, you know, like Jim here, maybe, you know, like scientist who boldly goes out and sorry, you're the closest scientist to me, who boldly goes out, you know, they form a conjecture, you know, test it, maybe they make some discovery, you know, you see this in movies all the time. They make some discovery that nobody else has hit upon, and then they, you know, shatter the world with their earth-breaking discovery. I would argue, and I think most scientists would argue, and most philosophers of science would also argue that that is not, no surprise, not an accurate depiction of how science works. Another way of thinking about it is the famous quote that has unclear origin, sometimes attributed to Newton, but there's a whole thing on that, where, you know, standing on the shoulders of giants, like you're, yes. Sarcastic. Interesting. Yeah, I mean, there's whole essays on where this originates. It's actually pretty interesting, but but that's like another kind of model, you might say, like they're kind of building on top of one another. The sort of way of thinking about not just science, but more knowledge production in general that I probably ascribe to and I found useful for thinking about this question of what students need to know to navigate their studies in the world is this idea, epistemic communities. So it's talked about, Peter Haas is one big thinker there, but it's this idea of there essentially being a community of academics, working scientists, policymakers that all have knowledge that they can bring to bear on a particular area. And they, in some sense, are the people, so to speak, who validate the production of knowledge as it moves forward. They're sort of like where you need to go, so to speak, whether you realize it or not, to understand what the, you know, sort of current validated thinking is on a particular topic. And oftentimes it might be unsettled. There might be debate. There almost always are debates, but that's kind of where you need to go to figure out what the debates are, right? I mean, there's some things are debated, some things aren't. So this idea of epistemic communities becomes very important. And to get us to think a little more deeply about what we're doing when we think about epistemic communities, I want to pose one more question to you that's kind of similar to the previous one, but different. How do you know that the Earth orbits around the sun? So I want you to talk about that really briefly with the folks in your proximity. Okay, so is somebody willing to volunteer an answer that they or somebody they're talking to had to that question? Nick? So that's how there. Okay. So is that how you know?
No, that was what I.
Okay, okay. Anybody else have a answer that they? Oh, sorry. I was saying that she understands from recalling a astronomy class a while back that has something to do with the fact that we have seasons and the way that Earth tilts that indicates that the Earth orbits around the sun. Is in that area. Yeah. Yeah. So, okay, I think we trust, I mean, I would argue that probably most of us, maybe all of us, do know or think they know that the Earth orbits the sun because they trust scientists, because they trust scientists, or that they trust maybe, and what do we mean by science, right? Like, who are you scientists? It's a community, right? Like a community. We maybe not every scientist thinks the same thing. In fact, let's so this is the actual, this is the YouTube video. Earth actually does not revolve around the sun. Now, is there any, like, if you clicked on that, and I did this, I clicked on it, played it. Think that, can you imagine a scenario where the content of the video would convince you that the Earth does not, in fact, revolve around the sun? What would it take? Of it just inch by inch by inch convince you? So, anybody else? Like, so it's not a stationary center. Yeah. Yeah. Yep, exactly. So I actually heard you, David, say something. Well, okay, so just hypothetically, if you clicked on this and it proceeded to have some argument about, I don't know, that there's some, lizard people that are running things and in fact trying to trick us into thinking that the Earth revolves around the sun, but it doesn't actually, you would probably, I'm guessing, not buy it. Probably not. On the other hand, you clicked on it and it said, and I think you said something about this, David, that in fact the Earth doesn't revolve around the sun per se, but it revolves around the center of mass of the solar system, which happens to be kind of in proximity, like kind of within part of the sun. But if we were, for example, in a binary solar system where there was two suns, the center of mass might be kind of between them and we wouldn't be orbiting around any one sun, then you might buy that. I don't know. So I watched that video. That's what it was arguing. I was sort of like, that sounds believable. I kind of believe it. I almost enough so I'd be willing to do what I did just now and kind of spout off about it. I didn't really like verify it, but it did sort of fit with my, it felt like something that scientists would say. And it seemed kind of my, rough notion of how the world works. So here, I'm actually gonna go past the okay, this is what I want to scooch to. What this highlights is something, this is a term that was coined by the philosopher John Hardwig back in the 80s. This idea of epistemic dependence, the idea that most of our knowledge of the world is founded on trust rather than reasoning it out. Like if you really step back and think about it, we are like, there's very few things that we know because we just reasoned it out from first principles. In particular, the big issue, I'd say the core issue, and Hardwig argues this a little bit himself, is that we don't know what we don't know, right? Like if you think about the amount of times that you've had some assertion like the Earth going around the sun or something else where it's like, oh, I thought this to be the case, but then surprise, there's some counterintuitive thing that's actually true, like, I don't know, that tomatoes are fruit or something like that, then it's like that can happen, right? And there's very few arenas where I'd be able to confidently say, like, my knowledge can never be undercut because actually I misapprehended the situation and some other authority might actually have a different take on it that actually should supersede my own take. So we are really, 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 really like depending on other people. The crucial thing though, is that this is like a situation that we're all in. It's not like there's like some magic person out there that's like the person that we are dependent on. It's like everybody is essentially epistemically dependent. You might have expertise in one very small little area, like, I don't know, what you did your dissertation on, if you did a dissertation or something. You might have some level of expertise. Even there, though, it's, if you think about how your research or whatever was validated by others, it's still supported by a community of other people. If you think about like unpopular ideas that were later on adopted, as they had to, in the end, gain support, even if they were at one point unpopular, they had to, in the end, gain support from a community of people in order to be carried forward. Yeah. Sure. Yeah. Confirmation bias definitely keeps us kind of in particular tracks. Absolutely. So yeah, I mean, so this is not, there's not like, oh, there's the people in the know and there's the people that aren't in the know. Everybody's not in the know. Everybody's dependent on others. So yeah, even if we possess some expertise, it's very circumscribed and exists as part of a larger epistemic community. It's kind of magical in a way. It's sort of this emergent thing. There's this knowledge held by the community as a whole, which brings us to this idea, rational dependence. So if we think about what are the skills that we use to cope with our epistemic dependence, I'd argue that there's a skill set here that we kind of naturally use for the most part. I think there's ways you can step back and analyze it and hone it, and you can do that as an instructor with students, but it is something that we kind of have some facility with just without thinking about it a whole lot. So rational dependence is what we'd call the sort of reasoned dependence on the knowledge of others. So I'd say that on the one hand, I'm arguing, and John Hardwig argued that most of our knowledge of the world is based on trust in other people. But on the other hand, that doesn't mean that there's no role for reason. The role for reason is, how do you navigate that situation? How do you recognize when you need to seek out help? How do you assess whether there is a relevant epistemic community, where to find valid knowledge? How do you judge between competing claims, or when do you have to kind of step back and just sort of say like, well, these claims are competing and I don't have the tools to assess it, but they both seem like they have backers that are pretty, valid. So examples, I think, of where you can sort of find epistemic communities of action is like Stack Exchange. That's a website where folks in a lot of different areas, physics, math, chemistry, pose questions and they get answers to those questions. They share answers to those questions. This was actually a friend of mine. I posted this. This is my 3-year-old daughter at the time. This is a friend of mine who I sent this photo to him because I was curious if he could tell me why those circles were in the pavement, because my daughter, who was 3 at the time, was wondering this. It was at a playground, actually Washington Elementary, I think. And I didn't understand. I asked him, he didn't understand. So he posted it on Stack Exchange and we got some really great feedback on the question. There's another site, Ask Metafilter, that does a similar sort of thing where people can post questions and people respond to the questions. And so this is actually another little bit of research that I did. And this is what I was alluding to at the very beginning when I said that thing about questions and answers aren't just questions and answers. A key thing about how these conversations happen, well, first of all, is that they are conversations. It's not just like a question and then the best answer. Like, I don't know, how many people ever use like Yahoo Answers? I don't know if it's even used anymore, but it was sort of a little bit, but yeah. So that was a thing where you had like people posted a question, people answered it, people voted for the best answer. And it's like that. I'd argue that that isn't very helpful. That's not really how you generate knowledge. Instead, it's, information seeking like this is what we call a socio-technical practice. It's something where we work with other people, we work with tools. We need to attend to the communities of practice through which the information is sought and generated. This is kind of a similar concept to the epistemic community. And in particular, what you see in those question and answer websites like Stack Exchange, like Metafilter, is that it's not just an answer. Like you post a question and you get corroboration from multiple people. You get elaboration. You might actually, your question might have been ill posed. They might rephrase your question. Oh, it should be this. Or maybe there's an obvious subsequent question that should be asked. And the thing is, you don't know that necessarily coming into it. Again, this kind of falls in the category of you don't know what you don't know. And then there can be disagreement, but it can be productive disagreement. There maybe is not a single certain answer. And so people argue a little bit, talk about why they think their answer is the answer. This is coming to the end here. What are students kind of really learning? I would argue that a lot of what's going on implicitly or explicitly, I'll get back to Wikipedia versus YouTube there, but either implicitly or explicitly is how to navigate communities and when to trust the knowledge of others. I think that's a lot of what they're doing, even if that's not an intentional, explicit part of what's happening in the classroom and as they're going through their studies. That is like a large part of what is happening and indeed what they need to develop in order to navigate the world that they're finding themselves in. The Wikipedia versus YouTube is, I bring that up because that's a nice example of how teachers, I think, can affect this. And in this case, maybe for the worse, one finding from surveying a lot of students around the country, I asked them, what resources they use, which ones they trust the most. Students, on average, definitely trust YouTube over Wikipedia. YouTube over Wikipedia. Now, Wikipedia, there's people that edit Wikipedia, but it's monitored, right? It's screened. Has anybody tried to just like change a Wikipedia definition? It's very hard to do. Like you have to have good reason to change it, otherwise it's going to be changed back. And YouTube has basically no editorial control at all. Why do they say that they trust YouTube more than Wikipedia? Because teachers, when they were young, said, don't trust Wikipedia because anybody can edit it. Like, that's what they were literally told by their teachers when they were like in elementary school. They were not told that about YouTube. It just didn't come up. They didn't say that about YouTube. And so, like, on average, students think YouTube is a more trustworthy source of information than Wikipedia. And that happened because of, I don't know. That sounds like I'm slamming teachers, and I don't really mean it that way. I think not every teacher does that, for one thing. And I think many teachers don't do that now. I think that practice has evolved over time. It was just a way, I think, particularly early on when Wikipedia was first around, to kind of grapple with the fact that there was this editable thing. And of course, the idea was not to like send them to YouTube instead. The idea was to send them to the encyclopedia instead of Wikipedia, something that was like solid and firm. I think one thing to think deeply about, whether you have kids in being instructed or whether you're an instructor, is thinking about how the norms governing the use of online resources might be linked to learning goals. Like, it really depends on what the purpose is of the instruction. I think that governs in a lot of ways whether it makes sense to restrict students' ability to, just use resources as they wish. And then secondly, I would tend to default to saying, oh, maybe they should just be able to use resources, unless you can think of, and I think there are plenty of good reasons, but unless you have a good reason to restrict them from doing that. And there are good reasons, I think, but you just want to make sure you do have a good reason in mind for why you're doing that. The other facet of that is actually being explicit and talking about things, that the way that people use these online resources. I think oftentimes there's a tendency to, it's very easy to sort of tell kids not to use these things, when as the instructor, you might be using it all the time to like prepare lesson plans and stuff like that. You're like, oh yeah, I Google that. But you're maybe a little more hesitant about letting the students do that. But so instead you might reflect for a moment on how are you discriminating between the resources you're using? And then could you convey that? Could you communicate some of those skills to the students you're working with? So I kind of skipped over one little thing, but I think that's fine. Many thanks to the students who have contributed to the research. Let me know if you have any questions, and there's a bunch of references. Share that later. But yeah, I think we'll do a break, right?
Yeah,
Is that
take
the
a
idea?
quick break, and then we'll do some question and answer.
Okay.
Give her a surprise. Thank
Well,
you.
thank you. Yeah.
Folks who did not get a ticket. Oh,
Possible. Sometimes I feel like that's right. Actually,
Anyways, Fridays, we have, our hosts have actually talked about the maybe giving us some required giveaway for instance. So the computer or whatever, I haven't set that up yet. So today we are going to be giving away our last pair of Mickey Green socks, the last pair. After that, if you got Lakers items, and you can sell them on eBay for a lot of money. And we also have a copy because I need to go over some other things in one pair. So if you have any copy of the documentary, the watershed, hopefully you have some explains. It's on DVD. That's all. But we'll get out your numbers, different tickets, and we will do a drawing out of what I think is an ergonomic goggle or. Not sure what else. All right, number is 1371259. 259. Oh, we got a winner. You can take your. Oh, that's it. You can take your. Next three numbers 262. Excellent. So yes, we will. I'm rusty because we haven't done this in 3 years, so we'll hopefully have some more swag to give away in March for our repulsive Renaissance poetry speaker. So we'll hopefully have you guys back here in March. But now that we're ready, Andrew, you ready to take some questions? Some more questions. So you got a question during your talk, but we're going to ask away. So if you have a question, raise your hand. I'll try to go right ahead.
They are all now. Provided laptops.
Oh.
Instead of putting them, they're complete answers, and turning it in. How do we strike balance? I mean, technically, it's kind of technology to learn, and you get to get through whatever and the rest of your day.
Yeah.
You guys hear that okay?
I mean, sounds like that might be a situation where not having the laptop available might be good. I think that so you know, talking about when it makes sense to restrict or not, there's certain you think about learning mathematics, there's certain skills that it's useful to develop so that you can more easily deal with more sophisticated problems later on. And so I think there's a lot of compelling reasons for restricting the use of outside resources for specific things, and that might fall into that category. I do the sort of converse of that, well, not converse, but I think sometimes about students who not elementary or middle school students, but again, like college students, let's say, who are approaching, maybe this is like a terminal math class, and they have a lot of things that they're balancing. Maybe they're working, maybe they have 4 kids, maybe they have other stuff going on, and they are using resources like that to save time. Like that comes up a lot when I talk to students, that they're trying to save time that way. And it's hard for me to begrudge that. I think that that's sort of another topic, but it's like this question of like, what are the goals of the, like, what is the student's objective? What is the goal? And you could do, for instance, an analysis of, let's say you compared like a control group and a treatment group, where the treatment group had were using the internet more to get through their homework, and the control group was not. And let's say the great outcome in the end was like the same. There was the internet didn't help, or maybe even the students using the internet didn't do quite as well. That would be an outcome. But what if upon interviewing the students, you found that the students who were using the internet were able to tuck in their kids at night, or able to attend some event or spend more time with their family? That's pretty valid. That seems like, I don't know if that should be discarded as not the point of going through things. And so I think that it is really important to be holistic about it. But yeah, I mean, I hesitate to say obviously, but obviously-ish. Yeah, if students at an elementary school are just plugging in answers, I think you can make a pretty good case that they are in danger of not developing the sort of conceptual understanding that will help them enjoy and do better at these subjects as they progress forward. I think the purpose depends, right? So I think it depends on the math class, depends on the person. I'm very hesitant. I feel like there's pretty good arguments to be made that it's like it used to be the case that it was argued that it's like, oh, it exercises the brain and you kind of got smarter just by doing that. And I don't that might not hold a lot of water. But that said, I think there is, mathematics is very beautiful and it's a really fascinating and useful subject. And to the extent that either it might be great for students to understand more about mathematics in the same way that it'd be great for them to understand more about great works of art or novels or things like that, I think it's a wonderful thing in its own right. And then of course, yeah, there are practical uses for sure. What practical use is going to be best for what student kind of depends. There is certainly something to be said for like getting students to a point where upon say entering college, there's avenues that aren't like closed off to them. So there is sort of maybe an argument to be made for just kind of certainly at the K through 12 level, kind of getting them up to the point where like, oh, if I should all of a sudden be intrigued by, environmental science, I'm not like at a huge, I don't have like this huge hill to climb because I never really learned some of the prerequisite math for that. Yeah. I guess it's sort of the same thing in a sense. I think it's a matter of like understanding, to what it makes sense to use it for. We were just talking about that. And there's arguments made. I think, doctors have talked about using it to generate like letters to go to insurance companies. People have talked about using, I haven't yet, but using it to like generate recommendation letters, you go through and then like edit it. The one thing I did use it for, and I said that I did this, so I didn't put one over on my wife, but for a Christmas gift, I hid something in the tree and I asked ChatGPT to write a poem in Homeric verse, telling her that this gift was hidden in the Christmas tree. And it made me like a really nice little 2-stanza poem. And I wrote it in there and I told her that's how I got it, but that's, you get greeting cards, right? That have pre-printed things in them. So it's not like that weird to like, you could get a greeting card with a pre-printed message. Why not generate something? I think then the big thing becomes like attribution, right? Like actually it's an issue, not so much like it'd also be weird if you like got a greeting card that was pre-printed and then like copied it down and pretended that you came up with it, right? That's like not a big difference.
I think if you get artificial intelligence to tell your family that you love them in the right way, that might be stepping.
Yeah.
Pretty funny project. Eric said that expression to his wife. Yes, I love you as strongly as the music of Eric Whittaker. One day, like, say, well, yes, but
Yeah, I agree. I think you can't, that's the big thing. It exists, so you can't ignore it, right? Yeah. Sure. Oh, Mm. Yeah. Yeah, and I've actually had students say, not every student by any means, but some students say that they look at the comments to get a sense of whether it's trustworthy or not. Yeah, David.
Research area. One of the things that could be interesting, I don't know if it's enough data or anything like that, but was to sort of start tracking or analyzing your sort of community, epistemic community. That is cost free. I'm saying locally, almost everybody will say six. Being the green in this area. People you can definitely trust, talk about who is it that you trust? And the size, the result of the size of the community. And, other things that may be a much smaller community. And certainly when you move out of the math, the science, and the physical sciences, you start to get into more, you might think of the silos, just points, we're in the politics. There's no, there almost be no connection between this community and that community. Everything this community says, this community thinks they are, and vice versa. So, I mean, it seems to me, it's gonna take a lot of.
Yeah. Yeah, absolutely. Absolutely. That'd be really interesting. Yeah, Patrick. Okay, yeah.
The large shows, kind of hearing about this. It seems like a lot of it is surrounding students looking for what work is best for them.
So, okay, you're asking if I've seen any patterns in terms of if we think about like learning things efficiently as a goal, whether there is particular approaches that worked best for some people and work best for others. I don't know that it's tough. I don't know that I'm equipped to say like what's worked best for people. It's really hard for a number of reasons to get fingers on. I'd say if anything, like, and particularly like dividing it up by some sort of group. So I don't think I'm equipped to say that at all. I would say that there's kind of an interesting developing, I don't know if I'd go so far as to say consensus, but some strong patterns in the way students use these resources that I see repeated enough that if you want to hypothesize that the reason it's repeated enough is because it actually is something that's efficacious, then that might point to something that's helpful. And I'd say that the two things that stand out there are students looking, kind of shopping through lectures online until they find somebody that works really well for them that they can learn from. And they can, like, you know, it's good both because maybe it just works better for them than whoever their professor happens to be, but also they can pause and fast forward and rewind. And then the second thing is using like those answer engines. But again, that's like a fine line, right? Like it's would be easy to just copy things off. So I think to the extent that students are able to use it as like an aid rather than just a replacement for understanding, that seems to be pretty helpful for students. But this is kind of from their testimony. It's not like I've tested it myself.
I recognize that we are kind of past time, so if people have questions, I'm sure Andrew will stick around for a few minutes, but I want to let him get out of here and I recognize other people need to go, but thank you. I want to give a big round of applause.
Thank you.